My name is Rishi Divte. I'm the product manager for apps and integrations at Sumo. So if you're a customer, you've used Sumo Logic, you go to the app catalog, I manage the apps that go into that catalog. Okay? So earlier this year, we found a number of our customers were using Sumo Logic beyond the traditional DevOps and SecOps monitoring use cases, specifically to monitor their development pipelines. So let's just quickly talk about a development pipeline. And by the way, I'm going to basically reinforce a lot of the concepts that Mike from Gannett spoke about earlier this afternoon, as well as what Kosuke spoke about in terms of optimizing your pipeline jobs. So a development pipeline essentially is a series of automated steps to help developers get their code to production. So in any software development project or organization, typically what happens is a number of tasks are created by a dev manager or product manager, and those get assigned to a number of developers. The developer goes ahead, writes the code, checks it into a repo, a build gets created, which is basically, a build is basically a set of executables or artifacts, which then go through a number of test suites and then get deployed to stage and production environments. When this application is running in production, DevOps folks will assign production incidents back to development, and it goes back through that whole life cycle. So our goal here was to see if we can monitor these CI/CD processes for faster, efficient, and secure application development life cycles. So essentially what I mean by that is monitor all the data coming from these development tools. Okay? So this is looking back at what some of the folks in the industry have been saying. DORA, which is a research organization now part of Google, comes out with the State of DevOps report every year. And they survey about 30,000 tech professionals worldwide. And what they did is they developed this tiering system of organizations that are performing really well and are not performing well at all. So they came up with elite performers, high performers, medium performers, and low performers. And I'm going to talk a little bit about the elite performers group. What they found is, and I'm just going to talk about 2 or 3 important points. They found a lot of characteristics of this group, but the elite performers deployed code much more often. They had multiple deploys a day. Ramin was also talking about in the presentation today. Some companies deploy every X seconds. I don't remember that exact number, but the rate of deploys are very high with elite performers. Secondly, the time it takes from the code when it's checked into the repo to making it to production is very low. It's as less as an hour. And Kosuke talked about it in his presentation as well, is that you're running the test that piece of code is applicable for. So you're not wasting time towards getting code in production ASAP. So Gartner also came out with a report a couple of months back where they said that connecting the dots between your application deployment tools and your monitoring tools can significantly improve your deployments. Okay, so this is a report that came out in July. So what I'm going to do now is talk about 3 steps to get there based on examples that we've seen internally as well as what we've seen some of our customers do. And the first one over here is know your outcomes. And Mike from USA Today spoke about this as well. They had a very specific target. They knew what they were going to go for. After that, selecting the right data, making sure you get the right pieces of data into your monitoring tool like Sumo, and then finally using that data to come up with some actionable steps. Okay? So first I'm going to talk about knowing your outcomes. So on the development side, in speaking with a bunch of product people, development managers, the most important thing that they wanted to know was, which teams require the most attention. Right? Where are the regressions? Where are the bugs? Which teams or individuals are causing the most production incidents? So getting that information in is super important. Analyzing that information is super important. Secondly, this was a little bit of a surprise, but development teams want to know what the root cause of a build failure is. They want to know, is it their code? Is it because of some flaky tests? What's the root cause? Okay? And we all know this, but embedding security and compliance early on in your development lifecycle can be significantly cheaper than finding a security incident in production. Okay? So in the same report that Dora put out, they said that the ratio of InfoSec professionals to infrastructure engineers to developers is 1 to 10 to 100. So getting this done early, finding your vulnerabilities, fixing your compliance checks in your code itself before it makes it to production is super important, both in terms of time and cost. Okay? So on the QE side, I'm just going to give a quick example of our own QE team. So we run, as you know, in multiple AWS regions across the world. And we have these Jenkins jobs running across all of them with, with various test suites. So what they wanted to do is, first of all, get visibility into the test status across all of these deployments and understand the top failure reasons. So if a build is failing, if you get the same failure reason appearing in multiple deployments, you can quickly just focus on that, get that solved, and then unblock a number of jobs. Okay? Secondly, resolving build failures. So it's not just about going to Jenkins and figuring out what the problem is, but getting some stats about that build. How long is it taking? What were the tests associated with it? And so on. And then finally, increasing operating efficiency. One thing that Kosuke also spoke about in the earlier session was that it's expensive to run your CI jobs. Right? You can't just run CI jobs without thinking about the cost of those things. So understanding which developers are not running their tests locally before they commit their code to the repo is critical. Right? So the next step is selecting your data, and those of you who are familiar with Sumo know this already. We have a number of out-of-the-box integrations for development tools, so you can leverage that right away with Jira, GitHub, Jenkins, Spinnaker, Circle CI. It's important to get that data in, but more importantly, and Mike spoke about this as well, if you have any custom tools that are generating data or that are important pieces of your development process, make sure that that data is coming in as well. And one important caveat that I would add to that is make sure you select the right data. Sometimes those tools can spit out like big JSONs, XML files, whatever it is, but get the right pieces that are important to solve your outcomes. So just a quick example here. This is what our QE team did. They used a Jenkins plugin to get data from our UI tests, specifically captured the test results in JSON format, sent it to Sumo, and analyzed it. Just with this first step, they got a lot of success. Okay. So now I'm going to show you a few examples of how you can use Sumo apps to get to addressing these outcomes. So one of these examples is our GitHub app, where you're analyzing all GitHub pull requests. So you want to see which pull requests are open for a long time and make sure you unblock developers towards getting their code down the pipeline. Second thing is Jira. In a Jira app, we have this panel that specifically analyzes reopened issues. So there was an issue, it was fixed, but something happened again and it was reopened. So you want to understand who are the users involved in it and what was the reason for these regressions. Okay. This is a panel from our Ops Genie dashboard. So this is basically monitoring all the production incidents that have happened and identifying the teams that are associated with those production incidents. So you can see here right away that this blue team, which is the Kubernetes services team, has the most number of production incidents. So the important thing is to give them additional resources or training to make sure these incidents don't happen again. Okay. So this is our Jenkins dashboard, gives you an overview of all the builds associated with a particular job. So you can see, run durations, test failures, number of builds run with a job. Okay. Now, this is a really exciting integration. We worked closely with JFrog, who's right here on this. So JFrog X-Ray analyzes artifacts in your repo. So these could be your own own files. These could be third-party libraries that you're pulling in. These could be Docker images that you're taking advantage of. So what we did over here is we are reporting all the CVEs detected, associated files, unique artifacts, and so on. But more importantly, we take this information and correlate it with the Artifactory logs to identify who uploaded a vulnerable artifact into the repo, and secondly, who downloaded those vulnerable artifacts. So you can make sure that loop is closed, and you can address why this was done in the first place and inform those who downloaded those artifacts. The next thing we're doing with JFrog is also identifying all the containers that are running vulnerable artifacts. Okay, so this is by correlating X-ray logs with Kubernetes logs to identify containers that have vulnerabilities in them. Okay. This is another panel from our Twistlock app where you're inspecting all the fixes that are available, right? So there are vulnerabilities in your environment, and there are documented fixes for those vulnerabilities, and Twistlock is giving that information that we are showing over here. So there's basically no excuse. You see this, you need to you can go ahead right away and fix the critical and high vulnerabilities at the very least. Okay. Going back to our QE examples, troubleshooting build failures. This is an example of a Jenkins dashboard where you plug in the job number, job name, build number, and you get all statistics associated with that build. So this is another way of looking at it as opposed to going to a raw log and looking through what happened. So you can see the test case distribution, top 10 slowest tests, job run duration, the job associated with this build, job parameters, URLs, and you can link back to Jenkins from this dashboard. I was also talking about pipeline efficiency and making sure you're within your costs. So this is a dashboard in, again, Jenkins that shows job run times, right? And so it's important to identify which jobs are taking the longest because it's going to be expensive for you in the long term. And identify which jobs are taking the longest and why they are doing so. Okay? So these dashboards are fine. These are out of the box that Sumo provides. But I would highly recommend that you develop your own specific to your environment. And this is an example of what our QE team is doing. This is specifically analyzing UI tests that are run on a certain deployment. Okay? And they're tracking things like failed jobs, total jobs, the success rate of deploying to that, of jobs on that deployment, okay? As well as trends. So to quickly summarize, we talked about accelerating a development and building faster, efficient, and secure app dev cycles by analyzing all the data that's coming in from your CI/CD tools. 3 steps to doing that: know what you're solving, select the right data, and then acting on that insight. Okay. So I think we have. Okay.
Thank you, Rishi. Any questions?
Yeah, I have a question.
Sure.
In any CI, thank you, sir. In any CI/CD pipeline, there are a plethora of tools, right?
Yeah.
Whether it's in the CI phase or in the CD phase. The question that I have is, at this current time, I don't see a lot of these integrations from Sumo Logic into, and I can mention a couple of tools, right? They simply don't exist, right? Mm-hmm. So what's the strategy for that? I mean, do you have to build a custom collector for those cases, or what's your experience been, sir?
Yeah, so the strategy, product strategy wise, we're expanding our reach in that space because we've seen a lot of successes with our customers who are using, using Sumo to monitor CI/CD. So our product strategy is to expand in that space. Specific to your use case, so at this point, we integrate with Circle CI, Jenkins, Armory, Harness, Spinnaker. All of these are pretty new integrations that have come out. And we're also, and CodeFresh as well. So these are all the CI, popular CI/CD tools in the market. We already have integrations with Artifactory and JFrog X-Ray. But the plan is to continue to expand in that space.
Thank you.
Sure.
In the back.
Yeah, I was just curious about your query that you had in for the JFrog X-ray. You said that you identified which users uploaded the vulnerable artifact. We have something similar like that, but only our CI systems, which have their own defined users, upload artifacts. So I was just curious, do you guys have like a different architecture where different users are actually uploading artifacts? How do you? I'm just curious about that.
Yeah, so with JFrog specifically, what we're doing is we expect the JFrog Artifactory logs to come in along with X-ray. That's the way we can do that correlation. Right? So we tie the uploads, the artifact uploads in the Artifactory log with the vulnerabilities detected by X-ray. So that's how we're doing it. So in your case specifically, you'd want to get those two sources in.
Yeah, I could do that, but the thing is it would just show the CI system as the person that uploaded all the
Oh,
artifacts,
okay,
right?
okay.
So I wouldn't have an individual user. I was curious about how you guys have individual users. Is it just
Yeah. So in Artifactory specifically, what happens is, in the Artifactory logs that we've seen is, the user is specified. If there's something that ties it back to something else, then you could potentially do that, But yeah. Or that ties it to a specific build, right? Then you can go back and figure out the build number, using subqueries. That's what we're doing with X-ray and Artifactory. We have a subquery that basically ties these two pieces of data together.
Any other questions? Thank you. Thanks, Rishi.
Thank you.